Hello everyone, today we're going to look at usaco-training subset sums. In this problem we're given a number n, and then we're supposed to find the number of ways to partition this set from the set of numbers from 1 to n into two sets such that those two sets have identical sums. For example, for n equals 3, which has the set 1, 2, and 3, we can convert these into two sets. One with 3 and one with 1, 2, and then both of these have the sum 3, so this would be a valid set or valid combination. So for n equals 7, we're supposed to find the number of ways to partition the set 1, 2, 3, 4, 5, 6, and 7. So then the four ways would be first 1, 6, and 7, and 2, 3, 4, and 5, and all these or each of these subsets would sum up to 14. So we're just going to print the number of ways to partition these sets. Okay. So first, we have n. Okay, so first, if we find the sum or the sum from 1 to n, or the sum of numbers from 1 to n. For example, for n equals 7, you would have 28. And then first you need to check if the sum is even or odd. Okay, so if it's even, then there might be a solution, or there should be a solution. But if n is odd, for example, for n equals 6, your result would be 21. And notice that it is impossible to have two sums or two numbers that are identical to make an odd number, because it has like odd parity. So first, so basically if sum is odd, then you know that your answer is 0. Otherwise, we're just going to check the number of ways to make the sum of numbers divided by 2. So for example, for n equals 7, so that's basically step 1. So step 2, you know that the sum is equal to 28. So we're going to try to make 28 divided by 2, which is 14. Okay, so we're going to try to find the number of ways to make 14 as our sum. Okay. So let's just put out like an indexing. So we have 0, 1, 2, 3, 4, 5, 6, 7. Actually, let me redo that. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. So originally, you know that without adding anything, you would have one way of making sum 0 because you're using nothing. 0 ways, 0, 0, 0. Okay, so now after this, we're going to simulate adding a 1 to this. So then you know that because we can use a 1, we know we have one way to make 0, so then we have one way to make 1. And then after using 1, actually this should like retain like its original value. So these should also be 0. Okay, so now we're going to simulate adding a 2. You know that for 0 and 1, this would still be 1. Okay, so one way is to add a 2 to the 0. So then you would increment 2 by 1 because there's one way to make a 0. The other way would to be making a jump from 1 to 3. So then you would again add the value over here to there. So this would be 1. 0, 0, 0, 0, 0, 0. Okay. So now we're going to try adding a 3. You know that by starting from 0, you can you can like add 1 to 3. Or actually, you can first say that these would retain their values. Okay, so from 0, you can add 1 to 3. So then, you know that the original one would be 1, so then you do 1 plus 1 to make 2. Okay, so for 4 and 5, you add 1 way and 1 way. Okay, and these would be 0 as well. So now we're going to simulate adding a 4. Okay, so you know that for n equals 5, you have 1 way to make it into 9. So wait a minute. So actually, what I said before, I actually made a small mistake here. So okay, so you know that for n equals, okay, so we're calculating for n equals 3. You can actually make a sum of 6 from using 1, 2, and 3. So this would also be 1. Okay. So now we're gonna try to do n equals 4. Okay, you know that 6 is possible, so you can add 1 over here. So is 5. So is 4. So is 3. Okay, so for n equals 2, or for the j equals 2, you're going to try to add 4 to it. So you would increment the 6, so this would be 2. This would be 2. Okay, so that came from there, and then this, you can add 1 here as well, so this would be 2, and this would be 2, 1, 1, 1. Okay, so now we're going to try to simulate adding a 5. Now, actually, we should, and we're almost done. Okay, again. So from n equals 10, you simulate adding a 5, but since that goes over 14, you don't do anything. Okay, so for n equals 9, you add 1 to 14. Okay, for n equals 0, again, you do 1, 1 as well. So now we're going to calculate starting from 6. Okay, so again, you have over here, so you do 2. Okay, now for originally j equals 5, you know that you can make another jump to 10. So then this would be 3. And then from 4 over here, you can make a jump from 4 to 9. So then this would be 1 plus 2, which is equal to 3, 3, 3, 3, and 3. And these would retain their value. Okay, so now for n equals 6, okay, you know that you can start adding from 8. Okay, so we're going to start here, and then we're going to go increment the 14 one. Okay, so you start here, you go increment at this, so this would be 4. Now at n equals 7, you go increment this, 4. This would be 4, 4, and 4. Wait, actually, for n equals 10, this would be 3. Because there would be 2 plus, or actually, this should be 5. My bad. And then for calculating for j equals 9, you go back to 3, so you have 2. Then you 2 plus 2, 5. And then for 8, you have 2 over here, so it's 1 plus 3 equals 4. For 7, you have 1 plus 3, which is also equal to 4. And for 0, you have 4 as well. And these would just retain their value. Okay, so for our last step, we try to simulate adding a 7. Okay, so again, you know that these would just retain their values. Or, actually, okay. So first thing we're going to add, because we can make a jump from 7 to 14, so we can increment this by, actually I shouldn't have marked that. So okay, so we can first make a jump from 7 to 14. So you add this value to 14, so 8. And then this would be 4 plus 4, this would be 8 as well. Okay, so now for j equals 12, you know that you can add from 5, so this would be 3 plus 4 equals 7. This would be 6. This would be 7. Okay, so yeah, 7, and this would be 6, and this would be 5, and this would be 5. So then these would also retain their values. And now that we're adding the numbers, you know that since we're calculating the number of ways to sum to 14, here's our 8, and then our answer is actually this number divided by 2, which is 4. And this is because, for example, for 7, n equals 7, you have 2 ways, 1, 6, 7, or 4 ways. Okay, let's just take this for example. This actually generates 2 subsets because you have this as 1 and this as 1. So for this example, we have 3 more. So we actually generate 8 different subsets. So then our answer is this divided by 2, which is 4. Now this is pretty tricky, and let's get it coding. Okay, so subset sums. Okay. So let's include iostream, and let's also include stream. Okay. So we're given a number n, so let's read them, and this is from subset.n and writing to subset.out. Okay, so let's read n. Okay, so now we need to first generate the sum. Okay, let's call this sum or sum. So there's actually a formula, so sum would be equal to n times n plus 1 divided by 2. Okay, so now if sum is odd, then you can just print 0. Or else, basically, we're going to try to make sum divided by 2. Or we just divided by 2. So for example, for n equals 7, your sum would be equal to 28 divided by 2, which would be equal to 14. So we're going to try to count the number of ways to make 14. So let's make a dp array. So int dp of or we can actually make it globally. So we can make a dp. So the maximum value of n is 39. So let's just consider it 40. So then this could be like 2000. Okay, so you know that there's one way to make 0. Okay, so now we're going to try to simulate adding I. Okay, so we can actually reverse from the n and we try to add it. So then we can go for int I equals sum, or j equals sum minus I. Then j has to be greater or equal to 0. J minus minus. Then basically your dp of j plus I would be incrementing by your dp of I. So now basically we're basically done, and we just print dp of sum divided by 2. Okay, this should be f out. Okay, and this is subset sums. Whoops. Okay, and let me create the files. So subset.in. So for the input, we have 7. So let's run this. Okay, so it finished running. So we have 0, which is not what we want. Okay, so j equals sum minus I. J has to be greater or equal to 0, and then you would decrement j. So we can actually print all the values of these. Okay, so what we can do is that for each of our values, or after we're done, we can print out our dp. So for int I equals, or j equals 0, so you just loop through each of these. So you just go like c out dp of I, or dp of j actually. Oh, so actually my bad. So this, we don't actually have to debug, so there should actually be dpj. Okay, so let me run this. And there should be dp of j because we're basically adding the ith number, or I, to this whatever sum we have right now. Okay, so we have 4, which is what we want, and I'm just going to try to submit it. So my B problem and language. Okay, so here we go. Okay, so this is subset sums. Here we go. Okay, so subset sums. Yeah, 1 second. Okay, so this is usaco-training and subset sums. Okay, I got it. Okay, so it looks like we're reaching like integer overflow. So perhaps instead of using integers, we can use long longs. And since long longs have 64 bits instead of the integer having 32 bits, it can store more things. So hopefully it would not run into integer overflow. Okay. Okay, so it looks like that is right. Okay, if you have any questions, feel free to leave them in the comment section below. Bye.